So breaking the chain, aerospace research and test with an all-American aviation production. All right. Good evening, everyone. My name is Jeremy Walters, and this is an all-American aviation YouTube channel event. I'm an ATP, Master CFI, Major in the United States Army, A864 pilot, and aviation content creator. I love teaching, I love inspiring, and I love helping improve and build up the aviation community. That's a picture of me back in the day flying the A864 and then doing a little bit of float plane training out on Lake Buchanan, Texas, in a PA-12 on Whipline 2100s. Could not do this, could not do what I do without the support of my loving family. That's my wife, Talia, our 5 children, and my Luscombe 8E 1946 tail dragger, Betsy Blue, hangared here on the field in Temple, Texas. Paul is working some long hours tonight, and he won't be with us, but normally this program is assisted by Paul. Obviously, with me having my technical difficulties, we know Paul's not here because normally it's a lot smoother. He keeps everything up and running, but Paul's not here tonight. We'll catch him next time. So tonight we've got a really good friend of mine. We've been together, been friends together in aviation for, I don't know what, 15 years or so. Brian is a test pilot for Scaled Composites. And when I met Brian, he was a private pilot on my sophomore year of college, his freshman year of college. And he does all kinds of cool types of flying and stuff. And he's also a really big general aviation guy. So Brian has been in aviation for over 20 years as well. And tonight it is my great honor to introduce our guest speaker, test pilot Brian Maisler. Brian, you have the controls. I'm gonna stop share. You have the controls, good sir.
All right, I've got the controls. Thanks for the introduction. And yeah, like Jeremy said, we've been buddies since way back in college. Jeremy actually gave me my complex endorsement back when we were down flying out of Ormond Beach Airport in Florida. And so, yeah, I'm honored to come on this show and hopefully kind of give you guys a taste of what it is we do in flight test and how we do it, and of course relating that back to safety and also I think just some interesting stories. So I've got about maybe 20 minutes of stuff that just kind of to go through to talk about what is Scaled Composites, what's the history there, what do we do for those of you that may or may not be familiar, and then a little bit about my history and how I became a test pilot and what it kind of takes to go from being a general aviation pilot to becoming a test pilot. And then from there, I think we can open it up and I think please use the chat and please use the questions, and we can talk about what you guys are interested in knowing about flight test. If you want to go in a technical direction or you just want to hear more stories, we can do whatever whatever you want there. So please use the questions and chat to give us some feedback, and we'll try to make this interesting for everyone. So to jump in, if you can give me the screen share, I'll get the slide deck up. Okay, is that coming up for you?
Got it. And when in the world, and well, I see 2007, where was this at?
So this is post-college, so it's a little bit later than when we first met, but this was when you lived in El Paso, and we took that V-tail Bonanza.
Oh, okay, that was a great time.
So just to prove how long I've known Jeremy for and how much younger we used to look, there's Jeremy and I in 2007. So just a little bit of embarrassment for both of us there. So to kind of jump in, I'm not sure, let me try to make sure I get I can't see the chat window anymore. But just to get a little bit in the history of Scaled Composites, being general aviation folks, I'm sure some of you are familiar with scaled, and maybe some of you aren't. So I'll just kind of do a little bit of a recap of who and what scaled is and where we came from. And, kind of the history for scaled there. If you don't know the name Bert Rutan was kind of the founder of Scaled Composites, known for his trademark mutton chop sideburns there. And Bert actually was a flight test engineer at Edwards out in the, I think, 60s and 70s, I think it was, and flying F4s and stuff like that. And he left that job as a flight test engineer to found what was called the Rutan Aircraft Factory, starting with the Very Vegan up there. This isn't a complete history of the Rutan Aircraft Factory, but this is a few. Very Vegan there in 1972 was his first sort of home-built design. And this picture is actually, it's a picture of a picture. This hangs on the wall of my house. This is a flight that we did in 2016 with probably one of the most epic air-to-air shots I've ever seen. I am actually in the cockpit of the lead aircraft there in the Very Vegan. Charlie Spinelli is the guy that owns that airplane and flies one of the last flying examples of a Very Vegan out there. So Very Vegan started in 1972, and it's a pretty unique and out there design and got a lot of attention at the time, and a handful of people built them. He then started iterating and improving that design. There were some issues with the Very Vegan and its flying qualities that were somewhat interesting, and Bert addressed those, and the Very Easy came out in 1975. Which really kind of was a big improvement in home builds, and then followed by, of course, the probably more famous version, the Long Easy, which I'm sure most people are familiar with and have seen. That Long Easy in particular in that flight is Mike Melville's Long Easy. That aircraft has flown around the world with Mike Melville and another Long Easy with Dick Rutan. So both of them flew their Long Easies around the world. So the Long Easy, I think, was the airplane that most people recognize out of the Rutan Aircraft Factory. And it was kind of huge in the home built world. The Thorpe T-18, which I own, kind of came out around the same time. And they were kind of the two big airplanes that really made experimental home built something from go from something that you flew around the pattern on a Sunday at your home airport to something that you could really compete with sort of the standard category airplanes and actually get somewhere and do some real work in. So the Long Easy was a kind of a big airplane at the time, and still is. The Defiant was a twin engine version down there, you can see. So that was an interesting one. There's a few other ones that came out of Rutan Aircraft Factory. Boomerang and Catbird came later. Actually, those kind of Boomerang was kind of a Bert personal project, and Catbird came through Scale, but they're all still kind of Bert projects. So that's kind of how Bert got his start, was building these little things. And that eventually led way into bigger and better things. 1984, I'm sure most people are familiar with, was the Voyager. That was Dick Rutan and Jeannie Yeager. Flew around the world nonstop, unrefueled for the first time in the Voyager. You can find that hanging in the Smithsonian and the National Air and Space Museum. And so that was its own project, a little bit outside of Rutan Aircraft Factory, but same people. So Bert, kind of an accomplished engineer at this point now, started making the Beechcraft Starship Prototype. So if any of you have seen a Beechcraft Starship out there, there are not very many around still, but they do exist. Beechcraft Starship Prototype in 1986. Bert wanted to separate the experimental home built business from the more commercial business side for liability reasons. And so Scaled Composites was born. So Beechcraft Starship is the first thing that Scaled Composites made as Scaled Composites, separate from Rutan Aircraft Factory. So this is an 80% scale prototype of the what would be eventually became the production Beechcraft Starship. And that's the beginning of Scaled Composites. Now, throughout the years of Scaled, we've done a number of proof of concept and prototype airplanes. Some go places and become more productionized things, and others don't and are just kind of interesting concepts along the way. So this is kind of the condensed history. If you add the numbers up here, it translates to an average of first flight of a brand new, never before flown type about once a year, which is kind of an incredible pace for a lot of stuff. So very, very heavy on the experimental flight test side at Scaled, and doing it very safely for a number of years. We have had one accident at the company, but in all of these airplanes, there's only been one, which I think is still a pretty good track record for as much flight test as we do. So some of you might see some of your highlights in there that maybe you've seen before. The Ares we'll talk about. The Pond Racer, if some of you have seen that one, that was pretty cool. The Atom aircraft, that was an attempt to go into production, but it didn't quite make it. White Knight 2 and Spaceship 2, Global Flyer, Proteus, White Knight 1 and Spaceship 1, obviously, and the Strata launch as well. Were all scaled projects. Some of those get turned over to customers. So, for example, Virgin Galactic now has ownership and control of the Spaceship 2 and White Knight 2 program. Scale doesn't do that anymore. That has been handed fully off to them. Same thing with Strata launch, that is now handed fully off, but we do the that sort of initial prototype development and then hand it over. So kind of lots of cool stuff, lots of unique stuff along the way. And the reason that a lot of that stuff has been done safely is because of that safety culture that Bert instilled from the very beginning. Bert was a flight test engineer at a time when there were a lot of accidents at Edwards Air Force Base. He knew a lot of test pilots and flight test engineers that died doing flight tests. So Bert brought into Scaled a very safety conscious organization, and has really kind of enabled us to operate and do what we do successfully. So, we kind of pointed some of these out, but some of the big milestones you might know Scaled from, the Spaceship 1 program, the Ansari X Prize in 2004 certainly was the big event that I think led me to Scaled and know what Scaled is and be involved there. Global Flyer was another one. Steve Fawcett, another nonstop unrefueled around the world flight. Strata launch very recently you've seen was a Scaled project, now completely transitioned over to the Strata launch company. And Proteus has some pretty high altitude records up in the above 60,000 feet range. So that's kind of the brief history of Scaled, to kind of give you guys a hack of who we are and what we do and where we came from. So now, who am I and how did I get here and how do I do what I do? And my favorite quote here from back in World War II, never fly the A model of everything. Well, Scaled is the pre-A model of everything. So kind of making a career out of doing what this World War II officer said not to. So back in 2008 is when I started at Scaled, which is a little bit after college. And if this gives you any indication, that is a CAD drawing of White Knight 2, and that is an engine nacelle being laid up. So the airplane was not very far along through construction. When I joined the company, this is actually my training. Back in those days, training involved sending even engineers out to the shop floor. You better learn how to build composite parts. You better learn how we make our airplanes and how we do what we do. So I got sent down to the shop for a few weeks and actually helped build parts for the real aircraft as part of my training and indoc to the company. So what did I do? So I got hired not as a pilot, not as a flight test engineer. I got hired at Scaled to work on avionics. That's coming out of Embry-Riddle as an aerospace engineer. I actually had been working on a lab as a part-time job doing programming, having done some bigger sort of projects for some labs out there. So I had a pretty decent background in coding, despite the fact that it wasn't really included in my major. And so I got brought on to Scaled Composites to do the MFD. So a lot of what you're looking at here, this is actually a picture of the Virgin spaceship. So this is a little bit further evolved from when I left the program a long time ago. But a lot of this, a lot of these screens, a lot of this work is all stuff that that I developed from scratch. Doing flight displays with the moving map and doing all that from hand. Energy displays for glide energy coming back into the approach, and system synoptics, and controlling nav radios, comm radios, transponders, you name it. So that's kind of how I got my start, which actually jumping from that to being a flight test engineer actually is kind of a very natural transition, because when you do avionics, you have to touch every system that's on the airplane. If I've got to make a screen to talk about the feather system, I need to understand that feather system in great detail to make that screen. If I need to do the pneumatic system, I need to understand that pneumatic system in great detail. So it was a pretty natural transition with that level of knowledge of the systems of the airplane to then transition into being a flight test engineer on the program. And that's kind of how Scale does it. Transitions flight test engineers is kind of two schools of thought. In a lot of the military organizations, flight test engineers are kind of a career path. Whereas in Scaled, we take the design engineers, we take the people who made the system. So, avionics, in my case, hydraulic systems engineers, fuel systems engineers, and those sorts of things. We take the people that actually designed the system, and then we move them into the test organization as the vehicle goes into test, because they've got the most in-depth knowledge and the most detail of how that airplane works. And when things aren't going right and things are operating off nominal, they're the right person to know what to do. And so we take that skill set and then we train them. We train them to become flight test engineers, and we train all that stuff. And so a lot of the things that go into training a flight test engineer are actually kind of familiar to you as pilots: how to talk on a radio, how to have crew resource management, situational awareness, all those sorts of things we need to train as an engineer moves, design engineer moves into a flight test engineer role. And that's exactly what I did on this program. So actually my first sort of step into the cockpit was not necessarily on the Tier 1B program with the spaceship, but it was actually in this airplane in Proteus. And this airplane, Proteus, has been flying since 1998, and it was designed, everything old is new again. This airplane was designed to loiter over cities, to provide broadband internet access, similar to what's happening with Google Loon, similar to what's happening with other platforms, and actually SpaceX Starlink, the same sort of system. So back in the 1990s, we actually attempted to do this with a twin-engine jet, high altitude, long duration. That kind of fell through, but we ended up through a series of acquisitions owning the airframe. And then once you got an airframe that's got this huge ability to carry stuff under the belly, like this airplane does, there's not a lot of airplanes that can carry thousands of pounds of very, very large payloads underneath. You fly a Saberliner or something like that, it can carry the weight, but the payload's got to be small because the jet sits so low to the ground. This one's got so much clearance underneath that it's just found life again and again and again, flying all these sorts of pods. And so I got into this airplane in 2009, the first time in the right seat. And you can see that's actually a picture from one of those early flights. So in the right seat of this airplane, it's actually not certified because it's not certified, but it is experimental operating limitations have it as a single pilot aircraft. So the right seater is not a SIC in this airplane. The right seater is a flight test engineer. So you can see I'm there on a laptop interfacing with one of those pods, one of those payloads that's underneath the airplane. That's my job in the right seat, is to be the guy that deals with that the payload and all those other things, and then also assist the pilot with checklists and other duties as well. But my primary role there is as a flight test engineer. So that was kind of how I got my start. And this airplane is really, really awesome because it's it's high altitude, long endurance, and it'll get you up there. It doesn't go to the 60,000 feet that it set the record at, especially not with these big pods anymore, but it pretty easily and pretty regularly gets up to 50,000 feet with these huge pods, which is pretty good altitude. I mean, there are some biz jets that get up there, but not many. So 2009, I started in this airplane, kind of learned the ropes of being a flight test engineer. learned the ropes of flying jet aircraft. This is the first jet aircraft that I operated as a crew member of, but not as a pilot crew member at this time, but starting to get my feet wet with jet aircraft operations, with high altitude operations, and getting that experience as a right seater in this airplane, which was just, and that's why we did this with this airplane, and we still do this at scale with this airplane, is we put our flight test engineers, we put our sort of new and developing folks into the right seat of this airplane to get them that initial experience, because it's such a great platform for that. Eventually, spoiler alert, I did transition to the left seat of this aircraft a couple of years ago, and now have an experimental authorization for this aircraft as a PIC. Then kind of moving on to that, I then got into the flight test of the spaceship program. Spaceship 2 and White Knight 2 spent a lot of time in the control room on the ground. Also spent some time in the jet, never in the spaceship. I never flew in the spaceship, but I flew as a flight test engineer in White Knight 2, and White Knight 2 actually has a third seat. White Knight 2 is a 2-crew aircraft, has a pilot and co-pilot, and in the back seat, it's got a flight test engineer. So I started out as a flight test engineer in the back seat of that aircraft, but I eventually did transition to flying some, no kidding, SIC time in the right seat of this in the right seat of this airplane. And that's again, this jet, I've been to 53,000 feet in White Knight 2. Which is just a phenomenal altitude and performance. Here's kind of the best of some of my adventures, and we can go into more story time later if you want about some of these adventures in White Knight 2. So I was a flight test engineer in White Knight 2 for the first manned captive carrier. The very first time we had people on board Spaceship 2. I was the flight test engineer on board of White Knight 2 for that. In the picture in the upper right corner, the first time we did a cross country with the Spaceship 2 attached. So you can see there we ferried the Spaceship 2 and White Knight 2 all the way to San Francisco for a big Virgin America deal there. So we got wined and dined in San Francisco as crew members there. That was a lot of fun. And I was the flight test engineer on board White Knight 2 for the first powered flight of Spaceship 2, which is the picture on the left there. That's a kind of morning of walk out to the airplane that was a little bit set up by the photographer, one of my friends. This kind of a little bit planned crew walkout for the first powered flight of Spaceship 2 in the morning. And then that's a picture on the bottom right is the spaceship after the first powered flight of the Spaceship 2 aircraft. And then I was in the right seat for a handful of flights of White Knight 2. The only significant one worth mentioning is I was the SIC in White Knight 2 for the first feather flight of the spaceship. So I got to see drop the spaceship, push the button to drop the spaceship, and actually got to watch it go into feather as we circled around and tried to chase it down, which obviously we can't achieve those descent rates in White Knight 2 that the spaceship can in feather, but we tried. So lots of really, really cool experiences on that program, and it was a good time. So that's kind of maybe as much as there's a lot more flight test engineering career that happened, but I think that's kind of the highlights of it. So how did I get from being an FTE into being a PIC as a test pilot? Well, one thing I did is I bought an airplane, bought a Thorpe T-18 and just flew it tons and tons and tons, 500 hours in this airplane, and did a lot of formation training and to kind of break out into the safety bit again. If you haven't done formal formation training is a hugely good idea. If you're going to be out there flying around, can you legally fly formation with your buddies if you've briefed them? Yes, without formation training. Legally, you can fly formation without formation training. Is it safe? It can be if done rightly, but it's really a good idea if you have the availability. And there's so many organizations out there that do it now. to go get the formation training and go from kind of, be this gaggle to this, much more formal thing. And this actually really helped me when I moved into being a test pilot, because you fly chase all the time, and having really, really good fundamentals, really, really good skill set in formation really helped me in the transition to being a test pilot, because now the chase role, that's all sort of stuff that's ingrained in me. I know how to fly formation, and it's not something new I'm trying to learn. Organization out there, I fly with the All Red Star organization. They actually fly Yaks and CJs and the Russian equipment that came over. But they actually are very, very friendly to mixed types. So they had no problem taking me on with my Thorpe T-18 in their Yak group, and they're a very, very professional group, and do very, very good formation training. So them or any of the other type clubs, I'd recommend, if you're interested in formation, definitely look those guys up. They're more than happy to help you train and get you what you need. So then, after getting about 1,000 hours of total flight time, all sorts of variety of experience, I actually was able to get internally hired at Scaled as a test pilot. And so the first thing I got to fly as a test pilot is this airplane here. This is the Firebird demonstrator aircraft. This is becoming a production aircraft as well, manufactured by Northrop Grumman. So I first flew this airplane in 2015. The airplane first flew in 2010. And we were using this as a research and development test bed. So I got to fly all sorts of fun stuff. The picture here, the airplane in the background is not a Long Easy, but it's a modified version of a Long Easy made by a company called Task Research back in 1982. Scaled owns it now. This was a sense and avoid program. So flying in this picture, I'm in the Firebird, but we did switch back and forth between airplanes. So I'm in the Firebird aircraft, and my airplane is pretending to be a UAV. So, once we get the scenario set up, I hand it off to the control, or to the autonomous system. It's pretending it's a UAV. And that other little guy in the background, that Long Easy looking thing, he's an intruder. So we set up these scenarios, driving in at each other from long range, driving in at 90-degree angles to each other, doing overtake scenarios, and some of the other sorts of scenarios descending down into all the sorts of collision scenarios that are kind of typical or that have come out of accidents. And the goal was that the Firebird would then, as a UAV, detect that there was an intruder and then take the appropriate response. And so we got to do a lot of that testing, and that's, a little bit white knuckle, hand on the disconnect switch for the autonomous system, because most of the time in test it does its job and it maneuvers to avoid, but occasionally it doesn't, and it maneuvers to do something else. So you got to be ready to disconnect and take back control of the aircraft if the autonomous system doesn't do what it's supposed to do. So that was really, really interesting testing. And that was kind of my introduction to getting into test as a test pilot, doing the test planning process and going through all that. And that was just tons and tons of fun. And it was great transition for us, because not being a high time jet guy then, getting to actually transition into a prop, something that I know, have a lot of time in, and be able to work in the discipline as a test pilot was a really, really good training ground, sort of preparing me to move up. Then kind of moving into the jet world. Now, this was an aircraft that Scaled built. Unfortunately, only flew 7 flights before the program was canceled. The airplane was actually a really fantastic airplane. The program was canceled for other reasons. Obviously not going to be qualified to fly this thing in 2015, a year after becoming a test pilot. This is a little bit too high performance for me, but what I did get to do is fly chase for this in the L-39. So I got to get an experimental authorization in the L-39 as a PIC in the L-39, and got to do chase for this. So started to get to build my jet time doing chase for this program, which was a lot of fun and a lot of learning. This airplane was pretty awesome. It's like a T-38, almost identical to a T-38, but it's got a bigger wing, bigger tail, obviously, you can see there. And the airplane had a F404, the engine out of a legacy Hornet, but no afterburner. just dry thrust, no AB. Dry thrust, no AB from brakes release to 15,000 feet was under 2 minutes, which is just incredible performance. So I'm sitting there, the L-39, over top of the airport. If this guy took off when the L-39 was at 14,500 feet, this guy would be at 15,000 feet before the L-39. So I had to be at no kidding 15,000 feet over top the airport. Okay, I'm here. You're ready. Release for takeoff. He comes up. I stare down his inlets as he comes straight up to me for the rejoin, and he's at my altitude in 2 minutes. We're rejoined and starting test points 4 minutes into the flight. It's just eye-watering performance of this thing. It was pretty amazing to see. So now I've got my jet time as Chase in an L-39, and now I get to transition to my first real test jet. This is the Ares, first flew in 1990. It was supposed to be a gunship light attack, kind of an A-10 replacement, but more for like a helicopter attack role. Unfortunately, you can't see it in this picture. It had a gun on the right-hand side and an inlet only on the left-hand side. So that inlet you see there is only on the left side of the airplane. There was a gun on the right. There is no longer a gun on the right. So this was a light attack concept. They did have a 25 millimeter gun. They did fire the gun in testing to try to sell the airplane. Unfortunately, the Army didn't pick it up, but it continues to live on again as a test bed. So I got to get checked out in this airplane, single seat, no simulator. So really the prep for this airplane is, hey, you've flown an L-39, you've taken a check ride in an L-39. The examiner for this airplane was the same examiner that I had for the L-39. So to do all my instrument stuff, I did that in the L-39, showed that I could fly a similar performance jet and do all the approaches and all those things that are would be required for a type rating, or in this case, an experimental authorization. So I did all that in the L-39, and then hopped in this thing and did an observed check ride where the examiner basically just stands at the ground and looks up, and you call over the radio, I'm doing a stall now. And he goes, okay, you do the stall. And he goes, okay, looks good. I'm doing a steep turn now. It was all good. So, it's really an interesting thing to do a check ride in an airplane that is single seat and has no 2-seat variant and no sim. And just getting to fly it for the first time. You get all the briefings you can, all the gouge you can from the pilots that have flown it before, but in the end, you just got to hop in and use your experience and knowledge and to fly the jet. So it was a lot of fun. It looks like a big long easy with the jet engine, and it flies like a big long easy with the jet engine. It's a really, really nice handling airplane, with the exception of the asymmetry that you get because of the thrust. I know that when you put the throttle in on takeoff, that is going to be a whole lot of left rudder. But then once you get in flight, every time you change airspeed or every time you change throttle setting, the yaw is going to get away from you somehow or another, but you're never quite sure which way it's going to go whenever you make an adjustment. So we get a yaw string in there, and you're just always kind of tweaking it to get the airplane to fly coordinated. So that's all kind of developmental flight tests. A lot of the stuff I've been doing with this is testing systems and payloads and sensors and all that sort of stuff. Now it's time to get into experimental flight tests. Now I've got all this experience with jets and experimental jets. Now it's time to move into experimental flight tests. So this is the Model 401 aircraft that we recently made. So 2017 was the first flight of this aircraft of 401 X-ray Papa. It was 2017. 2018 was the first flight of 401 X-ray Delta, and that is actually me in the airplane on the first flight of the second serial number aircraft. So now actually getting to move into experimental flight test and really doing no kidding first flights. This wasn't the first flight of the type, but this was the first flight of this airframe, and I did get to fly obviously the X-ray Papa before jumping into X-ray Delta, but getting a single engine, single seat, no simulator jet, and lots of interesting stuff there. If that's an interesting area of conversation, we can talk about envelope expansion and how you go about doing that safely and doing that whole process. But that's just a ton of fun, and Just a really, really, I love that airplane. It's one of my favorite airplanes. It's a great jet and does really, really good work. So that's kind of the summary of how I got here and how I got into test. And so, how do we do test? How do we do test safely? And I want to give you guys kind of a little picture and overview of how that really, really works. And, kind of the first foundation is test safety comes from the test culture. Really, the culture of everybody that does flight test is all about safety, and there's a lot of organizations to support it. The big one for test pilots being the Society of Experimental Test Pilots. There's most of the active test pilots in the world belong to the Society of Experimental Test Pilots. We have an annual symposium where most of the active test pilots in the world get together and the company walls come down. We have an environment, a symposium where everybody says, the companies, the loyalties of the companies are aside. We're all here to talk about safety. We're all here to share lessons learned. What's happened in the last year. Have there been any accidents, incidents, and all the test pilots get together and we really just have those no kidding discussions and presentations and kind of try to trade as much information as we can to keep each other safe. So it's really, really embedded in the test pilot culture. If I know something that could save your life, then I need to communicate that to you, regardless of company boundaries involved. So we have that outlet, which is a really huge part of the safety culture that is in the test pilot community. There's also the Society of Flight Test Engineers for the FTEs, and that's a little bit more focused on technical, but also has a very, very large safety aspect to it. Same thing with the AIAA, largely a technical organization, but they do have a flight test safety sort of piece to them as well. All three of those organizations have joined together and have something called the Flight Test Safety Committee. And the Flight Test Safety Committee is there to kind of be that the place where a lot of that information is kept and transmitted, the accident reports and things like that. There was a guy named Dave Howell who had a collection of accident reports filed by kind of, I think, category, this is, pneumatics related or hydraulics related. I think that's how it was organized. And so he had these, back in the day before computers, these file folders of accident reports. And he used to tell his flight test engineers getting ready to go do a new test, he would throw the stack of accident reports on their desk. And he said, if you're going to kill yourself, you better kill yourself in a different way than all these people did. And so the Flight Test Safety Committee actually has that sort of record of the accident reports of the flight test accidents that have occurred so that you can go and do that document discovery and figure out how everybody else has killed themselves trying to do the same thing that you're about to go do so that you can hopefully avoid making those mistakes. So huge safety culture in test, and it really supports, everybody really supports each other, which is a really good thing. So, kind of talk about maybe a little bit of the boring side of it, but, flight test isn't all just going up there and, slapping the stick around and seeing what happens. There's a huge process involved. So I just want to give you a little bit of an idea of what that process looks like. On the left side, there's the sort of design review process, and on the right side, there's sort of a test review process. So, in the design review process, we go through a lot of reviews. So there's preliminary design review, make sure that what we're about to go do and build makes sense. And there's critical design review at some points in there. And then there's the final design review, which is what did we do? What did we build? What are the margins? Are we actually happy with the design that we came up with? And then there's airworthiness, and that can be very, very different. Airworthiness can be hugely different depending on what organization you're dealing with. Military airworthiness versus FAA airworthiness. FAA airworthiness is incredibly simple and flexible, and one of the FAA airworthiness and the way FAA does airworthiness for experimentals is one of the reasons that in the United States we can be so much more agile and so much more innovative than a lot of other countries can be, because the way the FAA does experimental airworthiness really gives us a lot of freedom to be innovative, which is a great thing that we have here. So out of the design process, we got to generate a bunch of documents. We got to generate aircraft flight manual. We got to generate a maintenance inspection plan for this new airplane we just built. What do we need to inspect? When do we need to inspect it? We generally do an aircraft description document because the POH or the AFM, you don't want to put the whole volume of knowledge of how that airplane was built to something that the pilot's got to read. It's just way too much. So we have more information about the details of how the airplane was built in a separate document so that the pilots don't have to go through all that. And then obviously weight and balance comes out of that. So we get a bunch of documents. And that's kind of the big ones that we have going forward. And then on the test side, we go through a few review boards, and they're kind of important. So there's a technical review board, and then there's a safety review board. And the technical review board piece is evaluating whether the test plan that you've made is going to go get the data that you want. So in test, there's a thing we call necessary and sufficient. Is the test points that you've created, are they necessary? So we don't want to do testing that isn't necessary. Obviously the schedule and budget, but also safety. We don't want to expose ourselves to risk if we're not getting data from it that's useful. So are the test points necessary? If so, if not, then drop them. And are they sufficient? So if we're going to try to explore something, is the test that we've designed going to get the data that sufficiently answers the questions that we're going out to go for? So necessary and sufficient is really what the technical review board is all about, and the technical approach to the test. And then the safety review board is all those safety pieces. What are the parameters that we're going to monitor during test? What is safety of flight? What is safety of test? So we have these things called safety of flight and safety of test parameters that you wouldn't have in your normal cockpit. You've got, gear position lights and airspeed and altimeters and things like that in your normal cockpit. But in a test scenario, we may have a hydraulic system pressure or temperature that's being monitored that is really critical safety for a test point that we need to go execute, or angle of attack may be safety critical for a test point. And so we identify what those are and what needs to be working and for what test points, and go through a safety review board. And we also identify sort of the test specific hazards that go into that test point. So what is unique about what we're doing? If we're going to go do stall testing, what are the unique hazards to that stall testing, and how are we working to mitigate those? And we deal with all that in the safety review board. And then there's a final sort of flight readiness review, which is just a review of, are you really ready to go fly this thing? So those are the typical reviews that you have going into a big test. And documents, we have a test plan. As Jeremy will tell you, no plan survives first contact with the enemy. Same thing with the test plan. Once you get into test, you're going to discover things. You're going to find things that are different or new or surprises, and you're going to need to adapt. But so you think, well, what's the point of the plan if we're going to have to flex anyway? Well, you got to have something to start with. You got to have something to deviate from, and you got to put all your brain cells into what you were going to do from the get-go. And then when you're down the road and things are going wrong, you're at least deviating from something known, something you thought about, and then making those mods as you go. Training and proficiency plans, we need to figure out how we're going to make sure that the crews are trained. Test cards. So the test plan is great, but you're not going to take that in an airplane with you. It's just like a checklist. If we're going to do a very complicated sequence of test events, as pilots, we need to have something in the form of a checklist that's very, very brief, that just says you're going to go to A, you're going to go to B, you need to be at this airspeed, this configuration, and then we're going to do these test events. So the test cards are this kind of script-like, checklist-like sort of product that we use when we go fly to make sure that we're on track with what we're supposed to be doing. And then another big thing we have is the flight operation limitation. So we've got an airplane that maybe doesn't necessarily, we've got POH limits that we think we know what they're going to be going into test. We think that the max Mach number is going to be this. We think that the max angle of attack is going to be that, but we don't necessarily know. And sometimes we find things in test. And so we have to have a mechanism by which we can impose additional limits on a test aircraft and say, hey, until we go explore this, or until we go do this analysis or go do this modification, this is your new operating limit. And so that's, we have a place where we store temporary operating limitations when we're doing tests, so that we can either decide that, nope, that's no kidding a real limit, and that's going to go into the POH forever. It's just the way the airplane is, and then it'll go that way. Or yeah, we've done the analysis, or we've done the test, or we've made the modification, and that's no longer a limit. So that's, one of the ways we deal with those sorts of things. So then we got to get into the test execution piece. How do we then take that plan and go execute on it? And so we've obviously got the planning phase, writing the test cards and making sure that flight by flight we know what's going on. We need to do scheduling and notification. We need to use airspace. We need to use telemetry frequencies that we have to coordinate. We need to use airport services sometimes. So we need to go through a scheduling and notification. Everybody needs to be on board. And then there's a pre-flight, which is hugely different from maybe what you're used to in general aviation. Our crew chiefs do a very, very thorough pre-flight prior to every test flight, not just on the aircraft system, but also on the instrumentation, so that if we've said that we no kidding need angle of attack for this flight as a safety measure, that we know that sensor is in fact working before we go fly. So pre-flight is a very big and long process for a test flight. Then we get into the brief, which you see here. That's a briefing from the spaceship program, the Tier 1B program. So that's a very large brief, but we go through every step of what we're going to do, just play by play. Some of you that have been involved in military operations or things like that know what a briefing's like, and they're very rarely brief. So we do the briefing and then we go fly, brief the flight and fly the brief. There's a lot of rules of thumb associated with that, which maybe we'll get into. Then obviously, as important as the briefing was, debriefing after the flight is very important, and kind of recapping what was going on, what we found, what the plan going forward is. Post-flight inspections and data reviews all kind of happen through that test execution piece. So, so how do we deal with some of these things in tests? We talked a ton about process. There's a lot of process in flight test. There's the reviews, there's the documents, there's all that sort of stuff. There's a lot of process in flight test, as there is with, even, biz jet flying. There's lots of SOPs, lots of things. But as Colonel Wickert here has pointed out, that flight test is dangerous by nature. And by nature in flight test, we're probing the unknown and revealing previously unexpected cliffs, models, flaws, system deficiencies, flawed human factors designs, that's very big, and inaccurate design assumptions. So not infrequently, the cost of obtaining this data to reduce the uncertainty is realizing catastrophes. So the planning is great. The planning is very important. The planning has a big place, but the planning doesn't cover everything. In flight test, we don't know everything. We have this huge domain of uncertainty that we're going to go test. Stall characteristics are very hard to predict in CFD. They just don't work really well. And systems are very complex. When you build a new fuel system or a new hydraulic system, it's a very complex system, and all the simulation, all the modeling in the world isn't going to really tell you everything until you really get out there and put it in the aviation environment for the first time. So a lot of times in test, we're dealing with the domain of uncertainty. It's unknown unknowns. And so how do we deal with that? And what Beaker calls here, this is a picture from Beaker's presentation. We're dealing within the domain of where we're ignorant. So how do we deal with that? Well, we got to reduce the reducible ignorance when we can. So that's a lot of hangar testing. So we do a ton of hangar testing. Put the airplanes on jacks and swing the gear, put it on a mule and actuate the flight controls. And we go through tons of hangar testing. We reduce as much of the reducible ignorance as we can prior to go flying. But at some point, we still have to go fly with some ignorance. So the thing is process is really good with dealing with things that are risk, that are known scenarios. So risk is, well, his image here is the roulette wheel, or a roll of the dice. The roll of the dice is random, but it's always going to be 1 through 6, and it's always going to have the same statistical probability. And the same thing with the roulette wheel, and that's the airplanes that the airlines fly, and that's the airplanes that the biz jets fly, and that's those checklists that are developed. There's a risk any of those things could happen, and you don't know what's going to happen, but it's kind of a very well-known, very well-characterized system. So just because it's risky, you can use process to deal with risk. When you're dealing with the unknown unknowns, that's where the process starts to break down. And so that's when that's that kind of right stuff, kind of stuff that they talk about is that's when it's intuition. That's when it's gut feeling that you really have to go with the uncertainty. And that's where you try to spend as little of your time as possible. But, push comes to shove, is all the process in the world isn't going to save you from having to deal with the domain of total ignorance and all that uncertainty. And that's where you have to trust your gut as an operator. And that happens in real life and in general aviation too. There are certain times when you just have to go with your gut instinct. One of the foot stomps with this paper, it's not really included here, is there's a lot of times in the life of a test pilot where it's a gut call that something doesn't feel right, something's not right, I don't like it, which should be an easy call to make. But sometimes you're dealing with a program that's running over budget, running over schedule, and those things are hard, and those things have numbers. We know how much money we have left. We know when the schedule's due. So you're talking to people that say, hey, we don't have the money to do this mod. We don't have the money to go investigate this thing. And you say, but I have a gut feeling that we need to. And I think that's one of the points of this and this paper is because of what we do in test and sometimes in your lives too, when you're in that domain of uncertainty, that gut feeling is valid. That gut feeling is the best tool you have to say, I don't understand this. This doesn't feel right. So you really need to make sure you push against sometimes what seem like hard boundaries, and you don't feel, as strong with your gut feeling against someone who's got numbers. And it's easy to kind of get bullied, easy to kind of get pushed off because they've got numbers and you don't. But, one of the big things in flight test is go with your gut. If your gut tells you it's wrong, it's wrong. Don't get bullied into it. So the fallacy that happens in test and in real life for you guys in general aviation as well is what we call the turkey illusion. And that's the turkey first day out in the barnyard, farmer walks up, turkey doesn't know if the farmer is good, the farmer is bad, and the turkey is scared of the farmer because the turkey doesn't know. So, but the farmer comes out and feeds the turkey. So it goes, oh, okay, well, there was food this time. So next day, the farmer comes back out again. The turkey still doesn't really know, but there was food again. And over time, the turkey comes to say, well, you know what? The last time the farmer came out, there was food. Every time the farmers come out, there's been food. So you know what? This guy's okay. He's fine. And so now when the farmer comes out, the turkey goes running up to him because there's going to be food. Well, today's Thanksgiving. So the farmer's not carrying food this time. He's carrying a hatchet. And that's what happens when you kind of get bullied off your gut feeling. You get these other sorts of inputs, these things, it's worked out a million times before. It's fine. I've done this before. It's really not a problem. It's never been a problem. And you get kind of off of that initial gut feeling that just told you what was wrong. And that happens in flight test and that happens in general aviation, where you get that turkey illusion. Just, I've done it 100 times before. Guys do this with overgross takeoffs. Yeah, I've done an overgross takeoff 100 times before. It's been fine. It's never been a problem. I personally watched a Beechcraft, was a Sundowner or Musketeer. I actually, it was the eclipse. I was up in Idaho watching the last solar eclipse. And there were two guys on the ramp getting into I think a Sundowner or Musketeer, just crammed full of bags. Just everything in the back was bags and two guys. Oh man, that doesn't look good. High density altitude airport in Idaho. And I go, oh, you guys look overloaded. And they go, no, it's fine. We do this all the time. And I watched them drive right into the airport fence. Lucky for them, there was a golf course on the other side of that airport fence. So they were okay, but they did not take off. They went straight into the airport fence because they had done it 100 times before and it was going to be fine. So that's the turkey illusion. And we got to be cognizant of that. Then there's the zero risk illusion. That's, in flight tests, we categorize risk. This is a high risk test. This is a low risk test. There's been a lot of flight test crews killed when not flying test points, when flying things low risk. Because your guard goes down, right? This is low risk. Low risk is not zero risk. There's still risk. So, letting your guard down and just thinking that because the situation is low risk means that it's no risk is one of those fallacies that we constantly got to watch out for, and not just in tests but in general aviation as well. So those are two of the big ones. So I think that's all I really wanted to cover for just kind of the overview and what I wanted to talk about. So now I want to know what you guys, I think we got maybe, Jeremy, a half hour left?
Yeah, we've got at least a half an hour, but we can cut it short if we run out of content. But thanks, Brian. You can go ahead and minimize your screen now. And I'll tell you, the risk assessment slide that you had up just a moment ago, that was well put. That's the first time I've seen a risk assessment analysis discussed in that manner. In the Army, we use what's called the Army Risk Assessment, Risk Management Program. It's a little bit different. And of course, we've got various acronyms within the FAA that we use. But bottom line is having some sort of risk management process. And that gut instinct thing that you're talking about, it's not just something you conjure out of thin air. It's based off of all your experience that you acquire over time. And sometimes you don't have the full story. Sometimes you don't have all of the parts and pieces, but you've got enough to be weary and ask questions. And, you should always follow your intuition, your gut instinct, and ask questions and try to find out, the best that you can. And you kind of hit the head on the nail of things that I've dealt with before. And when you're flying along and you feel uneasy, it's definitely not the time to question your experience, because that gut instinct is all of your experience, your emotions, the knowledge that you've gained throughout the years coming to a head to warn you, be aware. So that was a really good discussion. That part alone was just a really good discussion. And I wasn't even tracking that you were going to bring that to the table tonight, but that was what I was really impressed with from the get-go. One of the questions that I always ask every presenter, and you and I have had, pancakes over at Denny's at 2 o'clock in the morning when we were in college, and we've flown around in Skyhawks all over Florida and done all kinds of cool things together. We've flown in formation over the desert in West Texas. And your definition back then of the question I'm about to ask you was probably way different then as it was mine compared to now. So you know what question I'm going to ask? I ask all my presenters, what is Brian's definition of a professional aviator?
Yeah, it's a good question. I know we've always talked about that back in college, but I think it's that, it's not just a job. You can be an airline pilot or a biz jet pilot as a job, and that's fine. But to be a professional aviator, I think is where we drew the kind of key difference in the word. And that's where it really becomes kind of a passion, where you really commit yourself to that continual learning process. I mean, you used to say back in college, the day that I'm done learning in aviation is the day that I hang up my headset. That's, very, very true. I think of a professional aviator is you're always trying to learn, always trying to improve, and always trying to get better.
Very good answer. And I think that 61-153, be of good moral character, I think it really needs to apply. As a professional aviator, if you're going to operate in this business, you've got to be a good moral character, and you just got to be willing to do what's right without being told to do what's right. All right. So some of the more cool stuff, some questions. First of all, the boomerang. All right. I can't even remember whether you and I have ever talked about the boomerang, but I saw it up on the display. Have you flown in boomerang?
Yeah, I've flown in Boom one time. I know the owner of it, and I probably should have flown in it more. But I've flown in Boom before. It's an awesome airplane. Bert wanted to sell that as the safest twin that there was. The fuselage is being staggered. The motors actually, the prop arcs actually overlap a little bit. And I have no kidding, done one prop windmilling, not even feathered, one prop windmilling, the other prop at full power, and taken it to a full stall, feet on the floor. And it does not have a VMC at all. It is
That's crazy.
It's crazy, yeah.
Yeah, and I'm sure we could spend probably an hour talking about how that thing, based off of the design characteristics, reduces the VMC characteristics of that airplane. But I've always thought that airplane is really, really cool, and it's just always appealed to me. I guess the next thing that you could get that would have no VMC would be a Cessna Skymaster, which is a really cool airplane. Have you flown one of those yet?
No, I haven't flown a Skymaster.
Flown a DC-3. He's flown a DC-3 from Scotland across the North Atlantic, bucking a headwind, going to Oshkosh. Why don't you elaborate on some of the highlights of that whole ordeal?
Yeah, that was that was a great trip. So that's a group of people of I think they're the DC-3 Society now, but the D-Day Squadron, I think, was what they were back then. And a group of 15 DC-3s went across the Atlantic for the 75th anniversary of D-Day. And I was lucky enough to be on the crew ferrying the airplane back across the Atlantic from Scotland back home again. So those guys have, I mean, if you know any of those guys have tons of stories, and it was just an incredible trip. I was lucky enough to just be a small part of it. But we took the airplane back out from Scotland and flew across to Reykjavik, Iceland, spent the night there, continued on, had to do a divert in Greenland. The primary airport we're going for ended up being IFR. A divert in Greenland in a DC-3 is a 2-hour proposition. So 2-hour divert to the nearest suitable divert field. Got some gas and continued on to Goose Bay, Canada. Luckily, the airplane was very trouble-free for all the water crossing piece. And no kidding, I was an SIC for this. I wasn't really a PIC, but I was doing the landing in Goose Bay, and the engine started acting up, no kidding, just after we had broken land. So I was telling Jeremy a little bit about some of those engine troubles we had once we got stateside, but I was very thankful that didn't happen until we got back over land again. But we did make it to Oshkosh.
Yeah, well, that was 2018 or 19, or I didn't make it.
I think it was 19. Yeah, summer of 19.
Yeah, I think I was preoccupied with. Oh, that was when baby Jeremy was coming. That's why I wasn't in Oshkosh 2019. So for now on, I mean, my youngest son and my oldest son will have birthdays during Oshkosh. But so why don't torsion and twisting forces along the center spar of the Stratolaunch center wing spar tear apart? What makes the wing so strong? That was one of the questions that was in the chat.
I'm really impressed by this question. I love this question.
Well, it was an engineer that asked that question.
Yeah. So the reason I love this question is because most people, when they ask about the wing, they ask about the bending moment. They ask, why doesn't it snap in the middle with 2 fuselages? And it's actually better with 2 fuselages because it's span loaded. It's like having all your gas in the outboards of the wings. The fuselages are actually reducing the center wing bending moment. So that's the question most people ask. This person didn't ask that question. They asked about the wing torsion, which is the correct question to ask about the Stratolaunch. But it's not just the Stratolaunch. It is the White Knight 2 and it is the White Knight 1 aircraft. All had these. White Knight 1 obviously had the center cockpit, but it had the 2 booms. And torsion is an issue. And if you remember about control reversal with flexible wings, when you get going too fast, that ailerons will actually twist the wings and make it roll the opposite way. That effect can happen with if you have a split in the pitch flight control circuit. So generally you don't get the torsion because the pitch flight control circuit's working in concert. So normally torsion isn't a problem because it's symmetric, but you have to deal with the asymmetric cases in design. And in both White Knight 1 and White Knight 2, it wasn't a problem. The structure of the wing was strong enough that it could take full torsion loads. And in Stratolaunch, there was some issues with that, where if the flight control circuit decided to hard over in both directions, that could be a difficult case for the airplane. So there was a lot of mitigations, a lot of thought into that specific thing, not because of the normal mode, but because of the failure modes. You got to mitigate the failure mode. So torsion in the center wing is a very big concern, but it has, I can't go into the details of it, but they definitely thought about it and mitigated it on the Stratolaunch airplane. On the other two airplanes, that load could never be big enough to actually cause a problem.
And I can tell you love that question.
What's that?
I said, I can tell that you love that question.
It's a great question.
Yeah, it's great. So one of the questions that was asked was, why build an 80% scale of the Starship commits you to design twice?
It's a great observation. It's a little bit of a chicken and the egg problem, and it's not necessarily the way that everybody has or will go with this. But the 80% model, it buys you data on the design. So if it's a risky configuration, like the Starship was, if it's a risky configuration design-wise, then it buys you a lot of test data, effectively, a real-world wind tunnel, rather than going and trying to fight for wind tunnel time. You just build a real airplane and fly it and get that initial test data. And then number two is it buys you a marketing tool, because you can't ever go in the aviation industry and get all the capital you need to build an airplane, a new production airplane, unless you're a major manufacturer, but even in this case, Beechcraft. But it's very hard to get the capital to go build a new risky design. If you're building another biz jet, you're building another airliner, that's one thing, but a new risky concept, have a hard time getting the money for that. So it's as much a marketing tool as it is anything else to say, hey, look, this is this configuration. This configuration really does work. It really is viable. And that you can start to get the capital to go build kind of the final design. And yeah, you do have to do a ton of redesign when you go scale it up to the full scale one, but at least you spent a lot less money to get that sort of initial proof of concept done.
What about ejection seats? Did any of those aircraft have ejection seats?
So the twin seat, the jet that made it to 15,000 feet in 2 minutes, that one had ejection seats. Ares originally had an ejection seat, but no longer does. And the L-39, which is not a scale-built airplane, that has an ejection seats. The other ones don't, and that is that can be a very contentious decision. And as guys, and even in the L-39 world, even L-39s, we had hot seats in our L-39s. There's a lot of guys that don't have hot seats in their L-39s, and the decision as to whether you have an ejection seat or you don't have an ejection seat is, even within our own company, a very, very difficult decision to make at times, because it's a very expensive proposition. It's millions of dollars added to your program, because you have to, it's not just as simple as buying a seat from Martin Baker and throwing it in the airplane. It's, you got to design around the seat, and you got to do the testing with the seat. So you've actually got to fire off ejection seats. You got to break canopies to really have an ejection qualified airplane. So it's a ton of effort. So we tend to not do it. But yeah, it's a good question.
This might be a proprietary question, but I'll ask it anyway. If you can't answer it, that's fine. What program languages did you use for the avionics? How does that design and QA differ from normal programming? I don't know how much you can answer that or not.
Yeah, I think I can answer that. I don't see a reason I can't. It was C++ that I did for the MFDs. It's still C++ as far as I know. Obviously, that program's out of my hands now. It's in Virgin's hands. But as far as I know, it's still C++. It was designed not to DO-178 standards because the MFDs and PFDs are not considered critical instruments for that aircraft. We have enough backup instrumentation and enough backup procedures in that airplane that we can get that airplane home without the MFDs. So we didn't actually have to design them to DO-178B standards, but we did follow DO-178 like processes where we could. And so there is testing, there is those sorts of things that go into it. And there's we followed a lot of we didn't necessarily follow to a T the DO 178 sort of standards, but we did try to use safe coding practices and those sorts of things when they made sense.
Understand. I got this question. Do they do ground vibration testing to look for divergent nodes before they for the instrument for flight?
Absolutely. GBT and flutter testing are huge things. So we do GBT. Almost all the projects I've been on, we've done GBT prior to flight. And so for those of you who don't know what GBT is the airplane, you've heard of flutter. There's coupling between the structure and the aerodynamics or structure and flight control. So there's lots of bending modes and torsion modes that the airplane has, and you can discover a lot of those on the ground by basically floating the airplane on these sort of floating cans and then using these big shakers to sweep through frequencies. So we do GVTs, we do flutter analysis, and flutter testing is a very huge part of envelope expansion. And in fact, the Model 401 aircraft, the first flight that you saw the picture of there, we had done GVT, we had done flutter testing of the first serial number aircraft of X-Ray Papa. That airplane had cleared its entire flight envelope flutter-wise. I got into X-Ray Delta, supposed to be the same airplane, supposed to be identically built. It's just the second airframe of that type. And as soon as I accelerated for the first test point, I got a buzz in the flight control system, a limit cycle oscillation, which is not quite flutter, but it's not what you want to see. And that was two airplanes that were supposedly identical. And that has to do with the VTAL. VTALs are particularly susceptible to it. And one airplane just was more susceptible to this limit cycle oscillation in the rudder vator system, and the other one wasn't. And we again, sort of that gut feel thing. Our gut feel says don't take credit for, and the test plan said, hey, we're going to do envelope expansion on vehicle number 1, but that doesn't mean vehicle number 2 immediately has the full clear flight envelope. We're going to re-clear the flight envelope for vehicle number 2. And good thing we did, because we actually found that. And that's something that escapes GVT, because that's a free play sort of issue. And you don't catch that in GVT. So even with GVT, it catches a lot of stuff, but it doesn't catch everything. And there's still a lot that you got to do in envelope expansion to make sure that you're safely and progressively expanding the flutter envelope.
Understand. So is being a test pilot something you wanted to do when you got hired at Scaled?
Yeah, absolutely. I don't know if I probably said it maybe when we were back in college that I really wanted to do that.
Yeah.
And certainly it was something I wanted to do when I started at Scaled, and a big driver for going to a company like Scaled, because as a civilian, it's one of the places where that path is kind of available. Now that being said, you can't go in. You can't go in thinking that it's going to happen, right? If you go into the company, if I went to Scaled and said, test pilot or bust, I probably would have been a very grumpy person for a long time, because it was about 7 years that I was with the company before I became a test pilot. But I went to Scaled because it was really awesome, and it was a lot of fun, and I enjoyed absolutely everything that I did along the way. Like if the test pilot thing didn't work out, if I wasn't a test pilot today, I would have still had just a fantastic career and a fantastic experience at Scaled, and still no regret. So yeah, I did want to be a test pilot when I wanted to work at Scaled, but it wasn't the only reason to want to work at Scaled.
Yeah. And it's really interesting that you go down that path, because I see where you're at now and I know where you were before. And when I came out and took the tour, and we chatted, you were just working on avionics. And, it's like someone we both know once said to us both, the most important job that you have is the one that you have today. I'm talking to and everything. And so it's, when I went in the Army, I wasn't an aviator or Army aviator. And, I ended up embracing the cards that I was handed, and voila, I ended up getting to fly, 64s. And you went and worked your way up the ladder and worked hard at it. And you're a test pilot now, which is really, really cool. And it's a testament of, your character and dedication to what you're doing for aviation, and you're a team player, which is really awesome. Which I was going to kind of close out on that, but we still got a little bit more time. There's a lot of good questions in here. You're welcome. Let's see here. Okay. I'm just going to read this verbatim because I know this individual, and so curious to know about the future of innovation in GA, especially given Scale's history. In the 90s was a gate, which gave us Cirrus. However, in the last 20 years, it seemed the time and dollars have been in VLJ market. If piston GA development relegated to experimental home builders, or is there a future for certified marketplace?
Oh man, yeah, no,
it's a long question.
It's a good long question. It's a good question. It's something that's really on all of our minds, and I think the answer is I don't know better than anybody else. I mean, right now the money that was in VLJs before, and actually even way more money than was in VLJs before, everything now is an eVTOL. eVTOL is where, if you want funding for an aviation-based project, it's going to be eVTOL. The Jobies out there and all the other companies that are doing these eVTOL projects, that's where people want to put their money right now. Whether or not that becomes successful, or whether it's a bubble that's going to burst, I have no magic 8 ball to say which way it's going to go, but that's really where the push is. And then sort of secondary to that is anything electric propulsion, electric aviation. Distributed lift is on a lot of people's minds. So it's all in that electric, it's all in that eVTOL. That's where the focus is right now in most of the aviation sector. There's not a lot going on in the certified marketplace for piston engine stuff. Unfortunately, there was a push a little while ago for diesel to try to get some diesel engine certified, so you could run your piston engine airplanes on Jet A and that sort of stuff. There was a push maybe 5-10 years ago for that, but that seems to have died down a little bit. So that's not the answer a lot of people want to hear, unfortunately. So.
All right. So I think we've arrived to a closing point, Brian. I want to thank you very much again for coming on tonight. And I really would like to get you down here to Central Texas, because have you flown in a gyroplane yet?
No, I've not flown a gyroplane.
You've flown helicopters, you've flown DC-3s and all kinds of really cool things. I'm not going to be able to get you in an Apache, unfortunately, but I can probably get you into an Apache sim. We can work that out.
Yeah.
But I want to get you up in a gyroplane because I think you're going to really love that. Do you have any closing thoughts on guidance to our audience? Is primarily general aviation folks. Do you have any kind of last minute guidance or anything you'd like to say before we close out tonight?
I mean, not really anything off the top of my head, but I just like what you said about the professional aviator. I mean, it's just, what you're doing here, all the people that are here on this Zoom, I think are obviously here because they want to keep learning. They want to keep improving. I think that's just the most, most important thing in aviation is keep seeking those opportunities and always try to, just make yourself that little bit extra better than you were before. And it's just a great community. I love the aviation community for that reason, that there's so many people like you and like these people on this, the conference out there. And I just love being part of that.
All right, man. Let's catch up on the phone after this call tonight. And, I really appreciate it again. I'm going to go ahead and close us out tonight, guys. One moment here. All right. So thanks again, everybody, for joining in with Brian and I. Give him a big round of applause in the chat. He'll probably see it. If not, shoot me a note and I'll get it to him. If any of you guys have any questions for me in particular, there's my email address, flyalamerican@gmail.com. As I mentioned, this is a All-American Aviation YouTube event. Breaking the Chain is a sub-series of All-American Aviation. You can help support me. These webinars are free of charge. Just go on to the YouTube channel, take a peek, go find All-American Aviation on Facebook and Instagram, and come back and join us next week. 2 weeks from tonight, January 19th, 7:30 p.m. Central for, once again, our guest speaker, AMP and IA and author Mike Bush, as he talks about proper engine break-in and environmental conditions. Aviation is proof that given the will, we have the capacity to achieve the impossible. Eddie Rickenbacker. All right. From Paul and I, he's not here tonight, but from Paul and I, and from Brian, and for everybody that joined in, thanks again. Y'all have a good night and fly safe, keep learning, and never give up on a dream. So long.